Hi, it's John Kelly here from Dalhousie University. I'm going to show you a little R script that I wrote to look at sort of a table of contents of NetCDF files. NetCDF files are used a lot in oceanography and atmospheric science, and they're pretty nice because they store the data in a compact way. It can be compressed, and it's ND independent. Maybe that doesn't mean too much to people now because so many machines are of the same endianness, but it's endian independent. It's also word size independent. So like the data can be read on, and again, this probably doesn't matter because everyone is probably using a 64-bit machine. But there was a time for sure when I was on a 32-bit machine, and it was really handy when people were getting 64-bit machines that NetCDF still worked. And the other thing, the really big thing, is that NetCDF is self-describing. You can embed meta information along with the information itself. Now, I'm in a Unix terminal that you're seeing here. It's on a Mac machine. I just did ls to list the files, ls for list, and there's a bunch of files in there. And let me focus a little bit on the files ending in NC. These are NetCDF files, and I can tell that by doing file, and this means that they're NetCDF files. It's NetCDF is a sort of a subset of this other thing, HDF. Okay, so I have a thing called NC Tools on my machine. It's a set of programs that do things with NetCDF files, and I think you can get it for many machines, but I just don't remember. I've had it for so long, I don't even remember where I got it from or how I update it. But I'm going to show you one that I use quite a lot, NC dump-h. I'm going to do it on this CTD file. I'll clear the screen there, but before I start showing you what comes out, I'm just going to say quickly, CTD is the machine that we lower from a ship. This is going to show some data from this machine that was lowered from a ship. And it measures the electrical conductivity of the seawater and the temperature and the pressure. And we get from pressure, we get depth. So those variables will be in this file and probably other variables as well. We're going to see in just a minute. Okay, so NC dump, what that will do, and I've given an argument of -h, which just means header. If I didn't give -h, it would show all the data, which is pretty handy actually. Show all the data in a kind of a text format that you could then read. I'm just going to show you the header here. I'm going to pipe it into less because it's going to be, I don't know, a couple hundred to 300 lines. Okay, so it's in less now. So what do we see? Maybe see we've got a curly thing here, and if I go to the very bottom, there's a curly thing there as well. So it's in some sort of a systematic format. Now you see here dimensions, it's only listing one dimension. Many times you'll see 3 dimensions, like one could be time, another could be longitude and latitude, maybe 4 dimensions for time, longitude, latitude, and depth, etc. This is one-dimensional data from this instrument lowered from the side of the ship, and there are 455 data points. And now there are variables. One's called depth, and it's double precision. Another one's called PRESPRA 01, it's double precision. And talk about this one first, this pressure one. And what it means, it's code that says, well, it's a vector, because these parentheses here, it's a vector. How many points are in there? And for that, you go up to here to the dimensions, and it's got depth points in there, 455. Now, if I return to this top one, you see it says depth for n depth. So it's saying there's a vector named depth, and the number of things in it is defined by the dimension called depth. That's why I want to do the pressure before depth, because it looks funny to see depth for n depth. Maybe I'm going to go down to pressure again since I'm talking about it. There's also some temperature in here, but we'll just look at the top part. Right, these are what's called attributes here. This one is sort of a little funny, but it's saying that there's time and longitude and latitude. Well, lon and lat, I'm sure, are probably defined in the file somewhere, but anyway, so we'll begin with the beginning. So here's the fill value. So, well, lots of data could be bad. It could be, the sensor didn't quite work, whatever. And so when you read things in R, this sort of gets taken care of for you. I'm not going to worry too much about that. I have another one called long name. And then there's one called parameter name. These are almost look like the same thing. Maybe they are the same thing. I don't know. There's a standard name, sea water pressure. And there's another name here, GF3 code name. The raw data file almost certainly, not the raw data file, but the second level data file almost certainly would have called it PRS underline O1. I mean, if you had two pressure sensors, the other would be O2. I say O, but I mean 0, obviously. What else should I say? It's showing the range. I never look at that actually because I'm always going to read the data, but maybe that's useful. And the resolution. Again, I mean, yeah, it's fine. It's got a unit in here, a unit of what's called a decibar. That's a tenth of a bar, and a bar is an atmosphere. And pressure has got the atmospheric pressure subtracted. So at the surface, it would say 0 decibars, and about 1 meter below the surface, it would say 1 decibar. That's the way that looks. So we also have a variable called temperature and one called CND, CS, electrical conductivity. It's in Siemens per meter. Okay, there's a bunch of stuff here. A whole bunch of stuff here. And, you know, some of them have funny names. PSLTZZ01. I mean, really? Anyway, just scrolling down. Okay, and then we get down to some things that are called sentiments, saying it's a string. String, gosh, it's not even a vector. And this is the string here. And that's in JSON format. And you could try to read that, I suppose. But R can read it fine, so it's not a problem. Okay, and if I go to the very bottom, there's also a bunch of comments down at the very bottom. So that's the great thing about NetCDF is it's self-describing. I find this format a little bit hard to parse with my eye, a little bit hard to scan. And there's some other things about it that that are just sort of, I think, non-optimal. So I've written something. Now I'm showing you the last 4 lines of my Z shrc file. I use the Z shell. And I made a function called comma NC. I start my own functions with a comma, so that will avoid name conflict. And basically you would say comma NC and then give a file name, and that file name would be inserted for this $* star there. Actually, anything that you give after comma NC will get. So it doesn't just have to be a file name. It could be Hello Kitty if that's what you wanted. And what's going to happen, it's going to run the following system command. It's going to run R script. That's where R is on my machine. And this is where I save this preview thing. And I'll just sort of show that to you now. Here it is. This is the R code that gets run. I use the NetCDF package. In the JSON Lite package, I have a function called NetCDF to TS, well, TOC for table of contents. And go down to the bottom here. And the other thing that I'm doing is I'm saying, well, I'm only going to let you give me one argument, which is the file name. If you give me none, I'm making an error message. And if you give me one, then I'm going to give you the output. Let's try it. Let's just see what we get. CTD, something like that. I'll pipe that into less. Okay, it's the same information to and now it's in a markdown format. In fact, I could type this into Pandoc and make a little document that would have, this would be a section, this would be the title, this would be a section heading, and these would be bullets here. Which I'm not going to do actually, but yeah, so I feel that it's kind of easier to read through. And if we go down to, let's say, the bottom, this is the pressure sensor. This is a calibration. So it's nicely named out that there's a variable called A0 or A0. It has this value coming out as a string. So to use it in a formula, you have to make it into a numeric value, but just use as.numeric on that, it's fine. And here's the coefficients for the conductivity sensor and for the temperature sensor. That's probably about all the sensors we've got, I think. Yeah, it is. What else do we have? You're getting the range. Oh, sorry. You're getting for longitude, you're getting that it's in degrees east, and which it should be anyway if people are being sensible, but might not always be. Standard name, and just forget about that. And this is the range, that is the allowable range for this. It's interesting, isn't it? Oh, sorry, the actual range. Yeah, sorry, just forget that. I thought there was an allowable range in this thing, but there isn't. So it looks like there's no difference between them. Well, that's because there's only one location here. Okay, so what's good about this? What's good about this is that if you already have R installed, which all the students in my kind of working group do in my classes have R installed, so you can run it. So you don't need to download this NetCDF stuff. That's one advantage. The other is that I think it's formatted just a little bit more cleanly for you. And in fact, if you look at it, I'll look at it again. You'll get a little lesson in how to work with NetCDF files. So I open the file and see underline open. The names of the variables are names of $var. I'm going to be using var names in a minute, but I'm also interested in learning about time if you have it, longitude if you have it, latitude if you have it. So I'm just stringing them into var names. And then I have a loop here for var names. Var name will be the first one in var names, and then the second in var names. It's going to spit out the heading. I'm doing a trick here, capture output, because what happens is that some things are in a 8-byte format, which I don't even know why they are, because you don't need 8 bytes for them, but that'll make a warning message, and I'm throwing away that warning message because it's not a problem. And then I'm saying, well, if it's a calibration, we run JSON late on it. We display that result. If it's not a calibration, we just do that. We just show the attributes. So basically what this is doing is it's getting all the attributes from this line. It's getting all the attributes for this variable. And then when I'm done, I have to do NC close to close the file. Actually, by the way, you'll notice I'm doing NCDF 4:::. I mean, I don't actually need it there. And I also don't need it here. So I could remove it from either, and maybe I will. So I have put this R code in a gist, and you can see the gist right there. I don't want you to have to sort of copy that down. So I'm going to put the gist link, this URL here. I'm going to put it into the description of this. I'm going to put this up on YouTube. So thanks for watching. I mumbled a bit, but hopefully it's sort of interesting to you. I will just say NetCDF is a great format. It's a really good format to learn how to work with. But do it on data you're interested in. Don't try to do it sort of hypothetically. Find some data that you want to work with, because then you'll be motivated and you'll actually learn. I just think you learn more by doing than you do by someone talking at you or giving you an assignment question. Take care and happy Labor Day. Take care. Bye.